Hey everyone, it's Justin again. In the last video, you learned how the quadratic formula can be used to find solutions to quadratic equations. The one thing we didn't mention, though, is that some quadratics have only one solution, or sometimes none. In this video, you'll learn how to recognize how many real solutions a quadratic equation has. By the end of this lesson, you will be able to use the discriminant to discover how many solutions a quadratic function will have. First, we'll learn what the discriminant is and how it tells you how many solutions there are. Then we'll work through two examples together. You'll have a chance to try an example yourself. You remember the quadratic formula, right? Well, it turns out there are a few pieces of information hidden within it. For instance, if we break apart the fraction and look at the left side, negative b over 2a, this indicates where the parabola's line of symmetry is. And the part with the square root is called the discriminant. When calculated, it tells us how many real solutions there are. As I'm sure you've deduced already, this video is a lot more concerned with the discriminant. When calculating the discriminant, there are three possible outcomes. The possibility we've seen every time so far is when the discriminant is a positive number. If this happens, then the square root of it is a real number, which can be either added or subtracted. So when the discriminant is positive, there are two real number solutions, one where you add and one where you subtract. If, however, the discriminant comes out negative, this means we wouldn't be able to take the square root, and the quadratic formula will be stuck without a real number solution. If a positive discriminant means two solutions, and a negative discriminant means no solutions, what's the third possibility? Don't forget, there's a number that's neither positive or negative, 0. If the discriminant is 0, then the quadratic formula will add and subtract 0, which both give the same result. Both solutions will be the same thing, so we say there's only one real solution. Remember these three possibilities because they can save you a lot of time trying to solve something that doesn't have a solution. Let's try a couple examples. By substituting the variables a, b, and c in the quadratic formula, we get this. Now we just need to simplify it, but first, let's check the discriminant and find out how many solutions there are. Here, let's pull it out of the quadratic formula for now. Negative 3 squared is 9, and negative 4 times 1 times 6 makes 24. And 9 minus 24 is negative 15. What did a negative discriminant mean again? That's right, we can't take the square root of a negative value, so the formula is stuck, and there are no solutions. Good thing we checked the discriminant first, or we would have done a bunch of work for no reason. Here's our next example. Now that we know how useful the discriminant is, let's just do it straight away. No point in writing out the whole quadratic formula until we know it's usable, right? Negative 5 squared is 25, and negative 4 times 2 is negative 8, times negative 6 is positive 48. 25 plus 48 is 73. At this point, the value isn't important. What matters is that it's positive. And a positive discriminant means two solutions. Okay, so I guess we do need to write out the quadratic formula. But finding the discriminant, we've already done the longest part of the simplification. Just a little bit more, and we've almost got the solutions. Two of them, because the discriminant is positive. Since 73 can't be factored, nothing here can simplify further. So these are our two solutions, one with addition and the other with subtraction. Do you want to try? All right, then here's a quadratic function. Use the discriminant to find how many solutions it has, and then find those solutions, if there are any. For the discriminant, b is 12, a is 4, and c is 9. 12 squared is 144, and negative 4 times 4 is negative 16, times 9 is negative 144. And of course, 144 minus 144 is 0. When the discriminant is exactly 0, That means there is only one solution. Let's use the quadratic formula to see what it is. We've already worked out the discriminant and got 0, the square root of which is just 0. And the denominator will be 8. Now let's split these into a plus or a minus. Negative 12 plus 0 is just negative 12, and negative 12 over 8 reduces to negative 3 over 2. For the other one, negative 12 minus 0 is still negative 12, and we just end up with negative 12 over 8 again. Remember, adding and subtracting 0 do the same thing, so our two answers will be the same. So we only have one answer here, negative 3/2. Remember when we talked about multiplicity earlier in this unit? Even though this is just one solution, we got it twice. So technically speaking, that root has a multiplicity of 2. Using the discriminant not only clues you into how many solutions to solve for, or if there aren't any at all, it also takes care of the hardest part of the quadratic formula before you actually do the quadratic formula. From now on, whenever you're trying to solve for the roots of a quadratic function, find the discriminant first. In the next lesson, you'll begin learning about another method of rewriting and solving quadratics called completing the square. See you then!